All right, so welcome. We're going to go on ahead and we're going to go through this review to make sure that we understand what all we need to do to be successful for our test on Thursday. So the first thing that we're going to go over here is the first 4 questions, and that is whether it is acute, right, or obtuse for your triangle. So remember, if c squared is equal to a squared plus b squared, it's a right triangle. If c squared is greater than a squared plus b squared, it's obtuse. And if c squared is less than a squared plus b squared, it's acute. So the first one here, we have 17, 20, and 12. Your longest one is always c, so 20 is our c. So c squared is 20 squared, which is 400. And then we're going to do a squared plus b squared. So that's 17 squared plus 12 squared. So 17 squared is 289, and 12 squared is 144. And then when you add those, you get 433. So here we see that c squared, 400, is smaller than a squared plus b squared. So since c squared is smaller, it is acute. All right, and now we'll do the next one here. This is a 3, 4, 5 triangle. So 5 is our c. So c squared, that's 5 squared, that's 25. And then 3 squared plus 4 squared, that's 9 plus 16, which is also 25. So c squared is equal to a squared plus b squared, so it is a right triangle. All right, next one here, 9, 15, and 12. 15 is our c, so c squared is 15 squared, which is 225. And then we have 9 squared plus 12 squared. So we have 81 plus 144. And so that's 225. So c squared and a squared plus b squared are equal, so it is a right triangle. All right, next one we have 6, 18, and 20. 20 is our longest, so that's c. So c squared, that's 20 squared, which is 400. And then we have 6 squared plus 18 squared. So that's 36 plus 324. And so that's 360. So c squared is bigger than a squared plus b squared, so this one is obtuse. Okay, and our last one, c is going to be 17, so c squared is 17 squared, and so that's 289. We calculated that from earlier. So we do 9 squared plus 12 squared, so that's 81 plus 144, which gave us 225. So c squared is 289, a squared plus b squared is 225. So c squared is larger, so it is also obtuse. All right, next ones. It says find the value of x and leave in simplest radical form if necessary. All right, first step. Look, this is a right triangle. So now look at your angles here. We have a 60, so we know this one right here has got to be 30. So we need to find x. So this 6, that is our short side, and x is our long side. So remember, on a 30, 60, 90, your short side is x, your long side is x times the square root of 3, and your hypotenuse is 2x. So we don't need to worry about y, we don't need to worry about the hypotenuse, all we need to worry about is the long side. So it's just x times the square root of 3. So our short side is x, or well, it's your short side times the square root of 3. So we have 6 times the square root of 3. And there's nothing special going on here, so it's just 6 square roots of 3. That's x. Okay, and y'all, on the test, it's exactly similar to this. Okay, now let's do number 7. Find the value of b. So we're trying to find this side here. Leave it in simplest radical form if necessary. So again, this is a 30, 60, 90. You can see here. This is our short side, and we're trying to find the long side. So again, short side times the square root of 3, that's the long side. So b is 5 times the square root of 3. Nothing to simplify, so it's just 5 square roots of 3. All right, next one here. List the angles of depression in the picture below. So depression. So this is somebody who's looking downwards. So always go and look at your horizontal line. Okay, there's the first one. And then we see angle 1. You have to go down. You have to look down. So angle 1 is an angle of depression. All right, go to the next horizontal line. I see angle 2. This person's looking up. So that's an angle of elevation. We don't want that one. But if they're looking angle 3, this one's going down, so that's an angle of depression. And then here's our last horizontal line. There's angle 4, and to follow the line of sight, you have to go up. So that's an angle of elevation, so we don't want that one. So angle 1 and angle 3 are angles of depression. All right, and then now they want us to list the angles of elevation. Well, we already did that. We look back here. Angle 2, you have to look up, so that's an angle of elevation. And angle 4, you have to look up, so that's our other angle of elevation. So with those, it's all about, are you looking up or are you looking down? All right, number 10. A zipliner jumps from the top of the castle. What is the distance he travels to reach the hill? So essentially, they've given us, this is a right triangle. They've given us the 2 legs, and they're asking us to find the length of this zip line. All right, and then we're wanting to know what's the distance that he travels to reach the hill. So this is a Pythagorean theorem problem. A squared plus b squared equals c squared. So we just plug in here. 50 squared plus 20 squared equals c squared. So 50 squared is 2,500, and 20 squared is 400. So c squared is 2,900. And so then we want the square root of that, because we don't want c squared, we just want c. So c is the square root of 2,900, which is 53.85, but we want to round it to the nearest tenth, so it's 53.9 meters. Okay, and so that's this side here, 53.9 meters. Now on this one, I'm going to kind of adjust this problem a little bit to make it very similar to one on the test for tomorrow. Let's think about the entire distance that he's got to travel. So to get up here to the top of the zip line, we had to add this 20 meters that he went up, right? And then you also have the zip line distance. So to find the total distance, it's the 20 plus the 53.9. So the total distance would be 73.9 meters. Okay, so the zip line part is the 53.9, but then for our test tomorrow, you're going to have to find a total part, so you're going to have to do some adding. All right, now let's do number 11 here. It says a firefighter must climb a ladder to reach the 3rd floor, and they want us to find basically they're asking us to find how long is the ladder. So how long is the ladder? Okay, and we're just going to ignore that because that's not what's going to be. So there's our question. So we have, again, 2 sides of a right triangle. We use Pythagorean theorem. So a squared plus b squared equals c squared. So 15 squared plus 20 squared equals c squared. So 15 squared, that's 225, and 20 squared is 400. So 225 plus 400 is 625. So 625 is equal to c squared. And we don't want c squared, we just want c. So c is equal to the square root of 625. And so the square root of 625 is 25. So the ladder is 25. So it's 25 feet. All right, number 12. It says use the special right triangle formulas to find the value of x in simplest radical form. All right, you got a right triangle here. This is a 45, so we automatically know this is also a 45. We have a 45, 45, 90. So if you remember about 45, 45, 90s, your hypotenuse is x times the square root of 2, and your two legs are both the same. They're both just x. So we have the hypotenuse, so we need to work backwards to just x. So to go from x times the square root of 2 to just x, we have to divide by the square root of 2. So this is what we're going to do. We're going to do 7, and we're going to divide it by the square root of 2. And you're going to have to do this on your test. Okay, so we have 7, and we're dividing it by the square root of 2. So we've got this. This can't be your final answer. Okay, answer choices like this will be there, but this is wrong. Square roots in the bottom, not right. So we have to take this and we have to fix our answer. So we do multiply by square root of 2 over the square root of 2. So you get 7 times the square root of 2. And then when you multiply the same square root by itself, you just get the number on the inside, so it's just 2. And then you look to see, can you divide 7 by 2? No, you cannot. This is as simple as it gets. So x is 7 square roots of 2 over 2. So that right there is pretty much like the only radical simplification you have to do on your test. So let's do this one here. Use a special right triangle to find the value of x. Again, it's a 45, 45, 90. So we have our hypotenuse, so we have to divide it by the square root of 2. So we have to do 13 divided by the square root of 2. And the square root in the bottom is a problem, so multiply by this fraction. And so you get 13 square roots of 2. And then on the bottom, when you multiply these two together, you're just going to get 2. And if you have trouble with that, just multiply the bottom in your calculator, and it will show you square root of 2 times the square root of 2 is 2. And then look, 13 and 2. Can you divide those? No, so that's just how it stays. So x is 13 square roots of 2 over 2. All right, number 14. The perimeter of a square is 200 feet. What is the length of the diagonal? All right, so perimeter. We need to find one side. So your side is the perimeter divided by 4. So 200 divided by 4, that's 50. So you need to draw a picture. So each side of the square is 50. And they're wanting us to find the length of the diagonal. Now every time you cut a square on the diagonal, you're getting a 45, 45, 90. Okay, this is a 45, 45, 90, both of these. So what we have, and this is every time for a square in the diagonal is 45, 45, 90. So we know the two legs, they're both 50. And remember, for 45, 45, 90, your hypotenuse, which is what we're trying to find, is just your leg times the square root of 2. So here it's 50 times the square root of 2. There's nothing going on here, so it's just 50 square roots of 2. That's your diagonal. All right, number 15. The perimeter of a square, so again it's a square, is 544 inches. What is the length of the diagonal? So first find the length of a side. So you do 544 divided by 4. So you get 136. So each side of your square is 136 inches. And then we need to find the diagonal. Remember, every time you have a square cut on the diagonal, you get a 45, 45, 90. And you know that also because the two sides are equal. and that only happens in a 45, 45, 90. So again, we need to find the hypotenuse, and so it's just the short leg times the square root of, or I'm sorry, the leg times the square root of 2. So 136 times the square root of 2. It's just 136 square roots of 2. That's it. All right, 16. What is the sine ratio for t, for angle t? So we're going from the point of view of angle t. And we want sine. Sine is opposite over hypotenuse. So remember from SOHCAHTOA. Okay, sine, opposite over hypotenuse. So for the sine of t, you look, what is opposite from t? 7. And then what is the hypotenuse? 25. So the sine of t is 7 over 25. And that's it, because you can't reduce that. All right. Number 17. What is the tangent for t? So tangent. TOA, tangent is opposite over adjacent. So the tangent of t is opposite over adjacent. So go in here, 25 is your hypotenuse, so label that right away. Opposite from t is 7, and so then 24 has to be our adjacent. So tangent of t, opposite over adjacent, so 7 over 24. And again, 7 and 24 don't have any common factors, so that's it. All right, 18. Use a trigonometric ratio to find the value of x. Round your answer to the nearest tenth. All right, you know when to use trigonometry? When they give you an angle and a side, and you're trying to find another side. So this one here, this is our 20 degrees. This 10 is opposite from it. And this slanted side here, that's our hypotenuse, but we don't know it. But x, that's the other number we have, that's our adjacent side. So opposite and adjacent, which one should we use? Sine, cosine, or tangent? Well, only tangent is opposite and adjacent. So the tangent of 20, it's equal to the opposite over adjacent, so 10 over x. Now when we've got the x in the bottom, all you end up doing is switching the x part and the tangent part. Like you put them in their same spots, but switched. So the x is going to come up here, and the tangent is going to go on the bottom. So x is equal to 10 divided by the tangent of 20. And so now you're going to calculate that, and make sure that your calculator is in degrees. So do 10 divided by, and then you press the trig button, and you get tangent, and you put in 20 in the parentheses, and enter. And you get 27.47. Now it says to the nearest tenth. I noticed y'all are having trouble on rounding. So you've got to look here. The 7 controls if the 4 goes up or stays the same. If it's 5 and up, it's going to go up. If it's 4 and below, like 4, 3, 2, 1, 0, you just leave it as is. This is a 7, so it's going to make it round up. So we get 27.5. So x is 27.5. All right, 18 or 19. Use a trigonometric ratio to find the value of y. All right, so here's y. This 12, that's our hypotenuse, and there's our angle 51. So the y from the 51 is opposite to it. So we've got opposite and hypotenuse. We need to use sine. So the sine of 51 is the opposite over the hypotenuse, so y over 12. All right, and we've got a number in the bottom, so when you have a number in the bottom, you just multiply it by the trig function. So this becomes 12 times the sine of 51, and that's what y is. So 12 times, and then go to your trig menu, get sine, and put 51 in there, and we get that y is 9.32. All right, now look at the 2. It's below 5, so it's just going to make that 3 stay the same. So y is 9.3. And yes, you have to be able to round on your test. If you don't round correctly, you're going to get that problem wrong. All right, number 20. A plane is ascending at 30 degrees and traveled 1,000 feet. How far off the ground is the plane? So we want to know how far up off the ground is this plane. So we have 30. The side we're trying to find is opposite to it. This 1,000 is our hypotenuse, so we need to use sine. So the sine of 30 is equal to x over 1,000. Opposite over hypotenuse. Okay, number in the bottom, we multiply. So 1,000 times the sine of 30, that's x. So 1,000 times the sine of 30 is 500. So the plane traveled 500 feet. All right, how tall is the tree? So we want to know how tall is this tree here. All right, we have, looks like this is 30 again. And so the hypotenuse is 120. We're trying to find the opposite side. So again, we're going to use sine. So the sine of 30 is equal to opposite, so x over hypotenuse, which is 120. So multiply by 120. So 120 times the sine of 30, and that's x. So x will be 60. So the tree is 60 feet tall. All right, 22. While walking his dog, Frank sees the Eiffel Tower. If the line of sight from Frank to the top of the tower is 2,215 feet, so that's your hypotenuse, that's the line of sight, 2,215 feet, about how tall is the tower? So we want to know how tall is this tower. So we're trying to find, there's our angle, we're trying to find how tall the opposite side is. And we have been given the hypotenuse. So we're going to use sine. So the sine of 55 is equal to opposite over hypotenuse, so x over 2215. So we've got the number in the bottom, so we just end up multiplying. So 2215 times the sine of 55. So the height of the tower, if we do 2215 times the sine of 55, you get 1,814.42. Okay, look at the 2. It's not going to make the 4 round up, so the tower is 1,814.4 feet. But if they ask you for the closest foot, it would just be 1,814. So they want, when they say about how tall it is, they're asking you for the closest foot. So it's 1,814 feet tall about. All right, now let's do this one here. Again, they're saying about how far is the kite from the ground. So they want to know to the closest foot here. Closest, or closest inch, really, because our units are inches. So closest inch, how high is the ground kite off the string? So they said the kite string is 100 inches. So remember, your string is the hypotenuse. And you're going to have a kite problem. So you need to remember that. String, hypotenuse. All right, we need to find the opposite side from our angle. And they've given us the hypotenuse. So we need to use sine. So the sine of 52 is equal to x over 100. So we're going to multiply 100 times the sine of 52. And that would give us x. So 100 times the sine of 52. So x is 78.8 as 0. So now we want to round it to the nearest foot. So this 8, you look at the 8 right there. The 8 is going to make, this is just about 79. It makes it round up. So it's about 79 inches off the ground. Okay, so that's it, guys. We've covered everything that's on this test. All of the stuff with the 30, 60, 90 and the 45, 45, 90, all of that is exactly the same as how it is on the test. So anything that I've done with the radicals as far as simplifying, so like on questions 12 and 13, it's exactly like that. 14, 15, exactly like that. All of these, every single question is exactly like one of the questions on the test. So if you go through and you study this and you can get this, you're going to do very well. And also notice how much work that I showed on all these problems. Even on the 30, 60, 90 and 45, 45, 90, you need to be showing me this work, because this, you need to show that to me. Okay, the simplifying the radicals, you've got to show that. Otherwise, you're not going to get credit. So go on ahead, watch this, study it, make sure that you know it, and you'll do excellent. All right, see you guys tomorrow.